Hello, 1212. Can you hear me? Does everyone can hear me now, or you still can't hear me? Okay, cool, better now. All right. So okay, never mind. I just need to restart the equipment. Okay, sorry about that. Yeah. So again, I would like to welcome everyone to Forward School webinar. So today, our talk going to be about Spotify and how they use AI to win a music streaming world. And today together with me is Daren Tan to talk about this topic. And yeah, so everyone can hear me. So again, let me introduce myself. My name is Hakim. For those who are new with Forward School, I'm the producer for classes and for workshop at Forward School. And for those who are never heard about Forward School, I'm not sure whether you guys heard about Forward School before or not, but just a briefly introduction is Forward School is actually more to a technology future forward school based in Georgetown, Penang. And we offer a software engineering program for SPM level and even upskill workshop for working adult. So that's a briefly introduction about Forward School. All right, so Daren, are you fine? Is it just me or Daren is hanging?
Okay,
Hello? All right.
Let me sort it out over here.
Okay. Yeah, so that's a big introduction about Forward School. We are based in Georgetown, Penang. And yeah, I just want to understand our audience today. We have around 27 people tuning in. May I know what is your background? So if you are from engineering or maybe arts or industry, may I know where you guys are coming from? I just want to understand who our audience today so that we can have a better communication. So if you can help me, yeah, let me know what your background. You can just say engineering, or maybe you can just say arts, or you can say admin. You can say, yeah, anything. Let me know. EE, okay, interesting. Engineering, physics, okay. Designer, interesting. Marketing, wow, we have quite a lot of gardener. Okay, I mean, yeah, it's okay. Okay, we have engineering. Okay, petroleum engineering. Wow, that's much more CS, computer science. Okay, cool. Quite have a variety of background here. SE, I'm not really sure what it is. SE, is it social engineering? Sorry about that. I'm not really sure what it is. SE. Darren, are you okay? Or are you still
Yep.
figuring?
Almost there.
Okay. While Darren are setting up his equipment, yeah, mechanical engineering. Okay, cool. Software engineering. Okay, quite a lot of engineering background.
Okay,
So it's a
ready.
bit technical. Yep. Okay, I can see you clearly, Darren. All right, CS. Cool. Oh, SE is software engineering. Oh, sorry. I'm sorry about it. I'm not used to it there. SE short term. Okay, cool. All right. So from what I'm seeing is our audience a lot of from engineering and even some from computer science and software engineering, which is cool. So most likely, maybe some of you guys are working adult, working as programmer or developer in your company, or even a freelancer. That's cool. And I even saw a gardener physicist, if I'm not mistaken. So that's cool. So right now we have 27 people tuning in. That's great. So before we start, I just want to set up tell you guys the rules for this webinar. It's a simple. So there won't be any recording for this webinar. So if you want to learn to hear what we'll talk today, or you want to ask question, do stay until the end, because we foresee that if we're giving recording to people, they will be slacking off. They don't really want to learn. They just tune in and then go away. So we really want to help. Want to give value to you guys to learn something new today. So we won't be any recording at the end of this session. And then if you have any question when Daren giving his talk, please put in the Q&A section. So in the Q&A, in the Zoom, right, they have this Q&A. Just put your question there. So at the end of the talk, we're gonna go back to your question and answer it one by one. So we are doing this so you are not interrupt when Tarun are giving his talk, so he can have his flow accordingly. So that if you have any question, just put in a Q&A. Don't worry, we're gonna answer it at the end of the session. All right. Yeah, that's more or less is how we're gonna go through for tonight. And without further ado, let me introduce our speaker for our topic today. Is about Spotify. I'm sure just before we start, just another poll. How many of us here in this webinar that actually using Spotify every day? Just yes or no. Just want to see a rough number. Let's see how many of us are actually using Spotify in their daily life. Yes, no, yes. Occasionally. Okay, yes. Never. Wow. Okay, no. Yeah. So roughly, Apple Music come out. Okay. So that's great. That's a good thing. No. So from this estimation, I would say like 50-50. So 50 of us using it daily, and some may just occasionally or never use it. Okay, great. So, but at least today you're going to learn about what is Spotify and who behind it and how they use AI to actually get people who listen to it every day. All right, without further ado, I would like to welcome our speaker for today, Daren Tan, which is also the founder of Developer Kaki group. If you from Developer Kaki, you should know Daren. And yeah, so I will pass it to Darren to introduce himself and continue with our talk for today, which is Spotify and how they use AI to actually win the music streaming world. All right, over to you, Darren.
All right, thank you, Hakim. Let me share my screen. All right, can you guys see my screen?
Yep.
All right, awesome. So look at the presenter view, swap. Okay, perfect. Can you guys hear me? Okay, perfect. So let's get started. Welcome everyone to tonight's talk. Wait, one more question. Can you guys see me? Okay, can see also. Huh? All right, perfect. Okay lah. So welcome everyone. Thank you for joining in on a Friday night. So sad that you guys aren't going out to TGIF, instead spending here to listen to me talk. Okay, thank you very much for that. Welcome to the talk. Today I'll be talking about how AI helps Spotify win the music streaming world. Okay. So a little bit of an introduction of myself. I'm actually a full stack generalist and data scientist. Um, I've in the past years, I've dabbled with web, mobile apps, software development, and slowly branching out to data science, AI, machine learning, developing chatbots, blockchain, and also a bit of UI UX design. Okay, I've worked in multiple startups. I've helped to bring multiple ideas uh, back to life in the past few years. I've participated in multiple hackathons, both locally and abroad. I've won quite a number of them as well, both 6 podium finishes and also top 10 finishes. And I've won a prestigious IT award locally in 2016, and I helped to represent Malaysia to compete on the international level. Okay. So currently I'm working as assistant manager in tech and innovations department in Magic, where I do a bit of web development as well as to do some research, some experimentation on how to use data science, AI, ML on certain mini projects in Magic that helps the startup ecosystem, as well as to attend meetings internally with corporates as well as with the ministry. Okay, currently Magic is under the Ministry of Science, Technology and Innovations. And Magic itself is in charge, for those who are not sure what Magic does, right? First of all, Magic does not provide grants. Magic provides capacity building, which are example like workshops, classes, trainings, accelerator programs to help to equip startups with the knowledge and skills in order to become successful startups, basically. Okay, so don't message me and ask me about grants because we don't have any of those. Okay. So next, I founded Facebook groups. I founded 2 Facebook groups, which are pretty huge. Hackathon Kaki, which is the one-stop place to find out about hackathon-related news. Currently, there's about 2,700 or 2,800 members, if I'm not mistaken. And the Developer Kaki, which has recently, I forgot to update this slide, recently has passed about 3.5K members. Okay. And also, since I retired from hackathons, I've been invited to judge in more than 11 hackathon entrepreneurial events. And I've been invited to deliver talks on various topics surrounding tech, career, hackathon, entrepreneurship. However, this is the first time I've been invited to give a talk on a technical subject, which is data science. Okay. So for today's talk, will be about Spotify, and I'll be talking specifically about giving you an introduction of how big is Spotify. I'll be giving you an introduction on what kind of techniques they use, which are mainly collaborative filtering, NLP, and also how they analyze raw audio. Okay, and I'll be ending the talk today with conclusion as well as a special announcement on special announcement lah. Okay. So let's start off with a quote from the founder of Spotify. Okay. The founder of Spotify is Daniel Ek. He's the co-founder and CEO. He said that music is not like news. Okay, news happened like 5 to 10 minutes ago, or 10 seconds ago, and only recent news matters, or recent news that people want to read. However, for music, it isn't like that. Music is a form of art. It is timeless. So basically, like a song from the 1960s could be as relevant to a listener like you and me today as, it could be as relevant as the latest Keisha or Blackpink song, for example. Okay. So how big is Spotify? Spotify is the world's leading music streaming service. It has more than 50 million song tracks, 3 billion playlists created by users. Unfortunately, I couldn't get the latest statistics for the subscribers and users, but this is based on 2017. 70 million paid users, which are subscribers, and 100 million users total, both free and paid, in more than 60 markets. So Spotify is extremely huge. As you can see, it's a service being used every day by people like you and me, and it's massively generating revenue. So here's a simple chart to show how big is Spotify. So basically, essentially, every 1 in 3 people that pays for music streaming services is using Spotify. They account for 30% of the market. And the only one that comes close to it is Apple Music, as just now what Hakim has surveyed. Some of you are Apple Music users. Okay, so the others can't even come close. And the reason for this is because of the the way they run the business and also the amazing tech behind it. Okay, so let me start off with a little bit of the history of music curation. Okay, so remember back in the days, right? We used to listen songs. Perhaps 1990s would be on the radio. If some of you are born there yet, so mostly on the radio. Then we transitioned to the big black disc. I don't know what's that called. I think it's called the records, right? Then from records go to CD that you buy from Pasar Malam or from an authorized store like Speedy. Then after that, we go to slowly go to digital form of music. From CD, we go to P2P, LimeWire. If some of you know that, back in 2000s, download music on LimeWire, and slowly in the 2000s, it transitioned from peer-to-peer music sharing the files, right? And then we slowly move on to music streaming services. Okay, one of the early pioneers in music streaming services is Songza. Okay, and even myself, I heard of this before. Perhaps it was not that popular. Okay, so in the music streaming services, right, what's important, right, is the music curation. If the music curation is good, it helps the user to stay on the platform by allowing them to discover more and more music to listen to. Okay, so for Songza, how they started out music curation, right, is by hiring a team of humans, music experts, or you would call it. Okay, they would listen to each song one by one, and they create their own playlist. These music experts are perhaps musicians, professional DJs, or music curators. Means it's a full-time job to curate music. Okay, so they'll be manually creating this playlist by hand that they think is good. This method works really well back then. They managed to grow a respectable and a substantial user base. However, the playlist, right, is created based on the music expert's own taste, and it does not capture the nuances of the individual user's taste. So therefore, this method, when you apply to more and more users, you discover that it doesn't really work for everyone. Okay. Next, we have Pandora. They use a slightly advanced approach where the music expert do not create music playlists by themselves. They create it. What they do here is they hire music experts to listen to songs and then add descriptive text on them. So what are descriptive texts? Descriptive text could be like describing the song, such as is it K-pop, is it folk, is it rock music, is it ballad music, right? So using simple keywords that describes the song, Pandora is able to create playlists that have similar tags, and you will have able to create playlists that have similar sounding songs. Okay, so with this, they have a data set that can create playlists that the user would like. Okay, so next we move on to Last.fm. Last.fm, they applied collaborative filtering to identify songs that user might like. So this will be discussed extensively later in the talk. Okay, and for Spotify, which is the number one right now, they use an engine to that use three different recommendation models. Okay, they combine the following data to analyze whether a song is similar or not, which is the user's interaction, okay, user interaction data, text data, as well as audio data. Okay. So next, this is a very familiar view. So this is basically the golden the golden pot of Spotify, the Discover Weekly page. Okay, that recommendation engine is used for this Discover Weekly feature, as well as the some other parts of Spotify. Okay, so mainly how this Discover Weekly work, for those of you that do not know, every Monday, every week, there will be over 100 million Spotify users that will discover a fresh new playlist, right? A fresh new playlist waiting for them called Discover Weekly. It is a custom mix, a custom playlist consists of 30 songs that they have never, ever, that you and me never heard before, but it's predicted that we will like it. Okay, it's quite fascinating whereby this Discover Weekly is able to know my taste better than anyone else, and it can really get it just right. And I would probably would not have found those songs myself, but Spotify just found it for me, and I really like the recommendations that come up from it. Okay, so this thing is not just based on my own experience or some friends' experience. So people on Twitter, on the public, also have tweeted about this on how scarily accurate Spotify Discovery is. Okay, Many others have experienced this phenomenon. So what makes Spotify's Discover Weekly features so powerful, so thick, right? So basically it's powered by data science. So underneath it, inside it consists of three main techniques, which is collaborative filtering, which analyzes both your user behavior as well as other users' behavior. Next, it also uses NLP models, which analyzes textual data. And lastly, it also analyzes audio models using CNN, convolutional neural network. Okay, so they combine these three methods in order to give you a very accurate recommendation of songs that you might like. Okay, so why they choose to use three methods and not just one, right? This method is called ensemble method. It's a collection of methods and it helps address the cold start problem. So what is cold start problem? Cold start problem is when you started applying machine learning models, and because it is new, right? They don't have much data, right? The platform is new or the model is new, the activity is new. You don't have much data to begin with. There's not much music preference user data to use. So let me compare one by one. So let's say we want to go for only collaborative filtering method, the model, it cannot work. It cannot work because there are no data to use or not much data to use in order to give accurate predictions. So you have to populate the data set with user behavior. So we have to rely on the subsequent tool first, which is NLP method. It can work because the data set is already on the internet. The lyrics and song titles can be used. Okay, the raw audio data also can be used because each song essentially is a raw audio data. Okay, so while we want to start using a model, when it's in a cold start state, you will need to use different models to combine their outputs to form a prediction. Okay, so here's a high level chart on how the Spotify architecture is. Okay, this is where the magic happens. Down here, you can see there's batch NLP models, batch audio models, batch collaborative filtering models. Okay, the dataset use are play logs, track metadata, news, blog, and text, and all these outputs to the goes to the recommendations pipeline, and after it gets processed, it will be on the Discover Weekly. Okay, so let's start with the first method, collaborative filtering. What is collaborative filtering? Okay, so collaborative filtering was made popular by Netflix when they applied it to their own recommendation engine. So each Netflix user, after they watch a movie or basically any other online platform, they will ask you to rate their movies or rate their products, right? To determine what movies or products to recommend to other similar users. So on Shopee, after you make a purchase, they also fill in a star on satisfaction, and also many other platforms like Amazon and many others. So for Netflix, depending on how you rate the movie, you will determine how much you like the movie, and then you recommend movies that you've previously rated to other users as well. Okay. However, for Spotify, as you've noticed, or for those that use Spotify a lot, they do not have star ratings. Okay, so they have to use something different called implicit feedback. Okay, so star ratings are explicit feedback, where the feedback is explicitly stated to you, while Spotify has used implicit feedback, which are how the user interacts with the software, how the user interacts with the song. Okay, data that can be used such as stream count of the track, how many times the user listens to the song, did the user add the song to the playlist, right? And after listening to the song, the user likes the song, and then the user visits the artist page to find out other songs by the artist. So all this user interaction is very valuable data that can be used to, perform collaborative filtering. So in essence, collaborative filtering is an algorithm that makes prediction on the user's interests uh, by collecting preferences from other users. So it's like collecting the preferences from other users is where the collaboration happens. And from that, you can make predictions about users' interests. That's where the filtering down the interest happens. Okay, that's where the name comes from. So in layman terms, in very short form, it's basically like crowdsourced prediction lah. Okay, so for example, there's many ways you can do crowdsourced prediction. For example, let's say you want to know whether which election party will win. If you can able to get a prediction, although not everyone voted, like you get a survey of who voted what, you can actually sort of predict what who will win, right? So yeah, it's a form of crowdsourced prediction, crowdsourced data gathering. Okay, so it's a very simple illustration from the previous CTO of Spotify. So here is two individuals. Person A says, hey, I like track PQRS. The next person, person B, he likes tracks QRST. So the common thing between them is track QRS and track QRS. So most likely person two, person B will like track P, while person A will like track T. Okay, here I explain in detail. So it is very, so how collaborative filtering works is that it compares users with similar tastes. It's basically, yeah, it's as I explained earlier. So it analyzes the data from many users. So it requires a lot of data points to work effectively, and then it determines the patterns of the similar ones, as in which songs you have listened to and which songs that the other person has not listened to, and then predicts the user's taste based on what other people have listened to. Okay. So let me talk a little bit deeper on how it is being implemented. So a very simple representation. So of course, in real life, each row, it was supposed to be up to 140 million rows because each row represents users that on the x-axis. Sorry, on the each row represents the Spotify's 140 million users, so there should be 140 million rows. And each column represents one of the 30 million songs in Spotify's database. Okay, so that's what the x and y axes are for. So ones represent that the user has listened to the song, while 0 represents that the user has not listened to a song. Okay, so this matrix is intensely huge matrix. Is being used, is being put through this matrix factorization formula. Okay, how it works is that it decomposes this huge matrix into smaller matrices, okay, in the product of two lower dimension rectangular matrix. So how this works, right, in illustration, it breaks down the huge matrix into a smaller matrix, which consists of the user vector as well as the song vector, okay. So the x-axis is the user, the x vectors are the user vectors, which represents the user's taste. So you represent the user each x matrix will represent which songs the user has listened to and which songs the user has not listened to. Okay, ones and zeros. While y is a song vector, which represent this song. This particular song has been listened by which user. Okay, so it becomes a song profile where you know, for example, let's say, what's the latest song? I've lost track of the latest song. So let's say the latest Blackpink song, How You Like That, right? So that song, which users has particularly listened to it, right? So you can analyze it from both ways, both from the user's perspective and from the song's perspective. Okay, so what you end up here with is 140 million user vectors, as well as 30 million song vectors. Okay, by itself, the vectors are meaningless because it's just a bunch of numbers. However, when you compare user vectors to user vectors, as well as song vectors to song vectors, you're going to discover similarities. Okay, you get to discover similarities. So how is this can be used is that example, let's say you compare user A to user B. You'll find out what are the common songs in relation as well as which songs they don't have. So you get to find users which have similar music tastes. Okay, you compare the vector and so then the output will be a list of users with closest matches. So this list of users with the closest match will be able to able to get the songs that each of them have not listened to, and then you recommend those songs to each other. That's how you can use the user vector to get recommendations. Okay, next is the song vector. The song vector, right? You can compare the song vector with other song vector to find out which song are listened by the same users, by listened by the same set of users. So example, let's say, who's a famous song right now? I cannot recall. I'm not sure how many of you know My Chemical Romance. So let's say they have 3 songs. The famous one, Black Parade, I Don't Love You, and some other song. Okay, so let's say an artist, for example, let's say an artist with 3 songs, and these 3 songs are listened to by set of users. Okay, so inversely, right, this set of users, they have the common ones as well as those who has not listened to this song. So you can actually get a recommendation of which users to recommend this song to. Okay. So next, let me move on to the next model. The next model is natural language processing. Okay, so this field is the ability, natural language processing is the ability of a computer to understand human speech, okay, as it is spoken, as it is typed, okay. It's often harnessed through using sentiment analysis as well as many other different techniques in order to dissect and break it down so that humans can understand, computer can understand humans. In layman term, it is a way to make computer understand human and human to understand computers. This field is one of the closest one to my heart and my primary research area of interest. So one day I hope to bridge the gap between human and computers using NLP. Okay, so next. So how does Spotify use NLP? So how they use mostly is word to vec and collocation. So word to vec is a technique and library that takes words and encodes them into, again, it's a vector. Okay, there's a lot of vectors involved here. So it takes words and encodes them into a mathematical representation. In these representations, vectors with similar shape would equate to words with similar meaning. So you get to capture the latent semantic meaning underneath, and it represents the implicit associations and also the relationships between words that we know to be true in everyday speech. How this it works will be explained in a later slide. Next is also collocation, as in which words appear frequently with other words. Okay, so how collocation works is that it is able to detect common phrases. Okay, detect common phrases from sentences based on how frequent two words occur together, otherwise known as the principle of collocation. Okay, the number of times, I can explain this using this formula. So this is the formula for collocation down here. The number of times two words appear beside each other in a sentence is represented by count, WI, word 1 and word 2. Okay, there's a deduction of the discounting coefficient divided by the multiplication of the number of occurrences of these two words. Okay, the reason why there's a discounting coefficient there is so that it can prevent excessive phrases containing infrequent words from forming. So this can adjust the accuracy. You can try to change the discounting coefficient to get a different variety of the collocation score. Okay. So next, although NLP is typically used on documents, on web pages, to find similar web pages, such as how Google indexes their page, right? Or other Word documents, such as research papers, such as news articles. NLP models surprisingly also works great on playlists, right? How they apply, Spotify apply here is applying them on playlists, where each of the title, which each playlist is treated as a document, while each song inside of a playlist is considered as words. Okay, so what Spotify does is very similar to how word to vec works, whereby it takes each playlist and treats them as a paragraph or block of text. And inside each song is treated as an individual word, and this results in a vector, right, that is a representation of the songs and can be used to determine whether two songs are similar or not. As such, the Spotify is able to determine which songs are similar to each other. Okay, so here are some techniques underneath. I'll explain, spend some time here to explain. This is from my own research slide. So I've used this technique in many areas in my research. So let me go on. Let me start off with these three techniques. So how this three technique works is it is a text pre-processing technique on how you can discover the latent semantic underneath of on how two words are similar in meaning, and they'll be represented in a space. Okay, so we first start off by getting a feature for those words. So how it works is that we create a matrix of words and their respective weightages by using the TF-IDF, which stands for term frequency in words document frequency technique. Okay, TF-IDF assigns weightages to each word in an article or in a document, depending on how important the word is. So for example, if the word, in this case, if it appears less frequently between all the documents. It appears less frequently within a document, it'll be assigned a lower weightage, a higher weightage, which means it's more important. While words that are repeated many times, like maybe or I am, those more common words are assigned a lower score, so that these will be able to emphasize certain words, emphasize the importance of certain words. Okay, so once you generate out this TF-IDF matrix, which generates a feature extraction of the document, you put that feature into latent semantic analysis. So what latent semantic analysis does is that it reduces dimensions. Okay, so for example, the matrix is n times n matrix. So it has many dimensions. So you want to break it down into a simpler representation. So what you do is you put it into latent semantic analysis, and it uses SVD to decompose the matrix. Okay, you decompose the matrix into a semantic space or representation from the corpus of text. The special characteristics about this LSA, right, is that two conceptually similar words, so in Spotify's case, songs, will be mapped closer together. So how closely, how it works is that the song titles are basically for the song titles, similar song titles or similarly context song titles will be grouped, mapped close together in that semantic representation. Okay, so once you have the latent semantic analysis output, right, you then can use cosine similarity to calculate the cosine angle between two word vectors. So this will enable you to cluster and also find similarities between two textual data. So basically words like, I don't know, pain, tears, crying, all these things will be on one part of the semantic space, while places like maybe Mulan, dragon, Chinese folklore, all these words will be in a different area of the semantic representation. So this is how this tree technique works in order for you to get that semantic representation, so that you can find and cluster closely related text together. Okay, so aside from playlist and song title, Spotify also crawls the internet to look for blog posts, text, or user comments written about music and songs. Okay, so they use text data such as the tracks metadata, the news articles about those songs that are being released, blog on what people write about the song, as well as many other sources around the internet. Okay, they scrape all this data and process it in order to figure out what people or what the general public is talking about the specific song or artist. So you'll be able to they'll be able to determine which adjectives or what language is being used to describe those songs. So songs that are similarly described with the same adjectives or similar adjectives can be grouped together and recommended to the users. So here's an example. Okay. So for example, let's say Dancing Queen, Mamma Mia. So all these can be using collocation. You can get the terms, right? Words that appear frequently together can be used as can be tokenized as a phrase instead of individual tokens. Okay. So words such as Dancing Queen appears together a lot. Okay, it gets a high score. Then over here in adjective terms, you get the perky, non-violent, Swedish, right? So this genre of this category of words, this category of terms are closely linked together, and you'll be able to recommend these songs based on these characteristics. Okay. So lastly, we move on to audio. So it's quite interesting. This is a very interesting part because you listen to songs every day, but have you ever wondered how, how can you analyze a song or audio? Okay, so let me give an example on how, let me explain how Spotify uses raw audio. Okay, so let's say Spotify does not use any machine learning algorithm at all. Okay, you keep on recommending the same songs over and over again, the same set of songs, and new songs will never be discovered. Okay, this model helps to add new songs to the playlist. So how this works? How this works is by when a user, let's say a brand new beginner songwriter started to write songs, upload to Spotify but you have no fans, no listeners, very little listens on this song. So there's not enough data. Okay, the collaborative filtering won't pick this up because no one has listened to it yet. The NLP model won't pick it up either because no one has mentioned it on the internet. Okay, so the good thing about raw audio analysis, right, is that it enables Spotify to analyze a song to find similarities in the audios from the audio perspective to other songs. Okay, it does not discriminate between new tracks and popular tracks. Okay, because you do not require in this raw audio analysis, you don't require the tracks to have a lot of data because it analyzes strictly on the audio data only. Okay, so the technique used here is called convolutional neural networks, which is a deep learning technique, and it processes the audio and produces characteristics such as key, what key the song is in, what mode is the song, what's the tempo, and what's the loudness. Okay, and why they need this third model? Because it further improves the accuracy of the music recommendation. It adds another dimension to the prediction. Okay, so let me dissect what is basically in the audio data. Okay, so over here, level 1 in a very high level, I mean the very basic level, you get from the audio graph, spectrogram of the audio, right? You get the time, you get the amplitude. Okay, that's all you get. If you look in the spectrogram, you get the loudness, which is represented by the hot, the hot color here, and also the frequencies. Okay, that's all you get, only these four. However, let's add another level. Okay, once you add another level of analysis, you get the melody, the beat, the voices in the song, lyrics, chords, and instruments used. Okay, and if you further analyze a raw audio, you get even more insights, even more dimensions to the sound from the audio data. Okay, so from here, the level 3 layer number 3, you get to determine the mood of the song, to determine the popularity, the genre, purpose, region, and era, strictly just based on the audio data. That's how much data you can get from here. Okay, so here's how a convolutional neural network, how a neural network works. There's many layers, and no feature extraction is necessary. It propagates the error backwards to learn optimal weights, and it needs a lot of data to work. And fortunately, Spotify has a lot of data. Okay, so let me spend a bit of time on how the convolutional neural network works in the way Spotify implemented it. Okay, so they input the songs and their respective audio spectrogram, okay, as the input data. So this audio spectrogram is essentially an array that consists information on the frequency, duration, and amplitude of a particular note during a song. Okay, so let me go further. Okay, all right. So as you can see, right, this neural network has 4 convolutional layers: 1, 2, 3, and 4. Okay. As you can see by the 3 thick bars on the left and the 3 dense layers. Okay, followed by narrow bars on the right. Okay, so the audio spectrogram are time frequency representations of audio frames which are concatenated, linked together to form the spectrogram. Okay, so then the next step is to multiply. Okay, see, look at here, the fxmp. So it's multiplied by another array called a filter to determine the presence or absence of certain features. So by multiplying with a filter, right, you get to detect the absence or presence of certain features in the song, such as the tone. Is it a sad tone? Is it a happy tone? Is it a major melody? Is it a minor melody? Or various, can be multi class. Can be is it high pitch, low pitch, or the multi pitch that it has. Mood of the song, right? All the different moods: happy, sad, angry, and disappointment, and all this stuff, right? So you get to filter out features each time when you multiply with the filter. So through this iterative process, repeat it 1, 2, 3 times. After that, after the final matrix of 35 times 512 is obtained, right? Global temporal pool layer is applied to generate insightful statistics, okay, like the mean and max occurrence of certain characteristics previously analyzed, such as tone, melody, pitch, and mood. Okay. So step 4, this will help to categorize the global temporals pooling. Will help to categorize the genre of the song just from the audio signal. Okay, you can try it yourself. Believe there are tutorials online on how to do this. So after you apply global temporal pooling, okay, you can use the data as an input. They will use the data as an input into a fully connected layer. Okay, the min max of the features are feed into the fully connected layer. Okay, this will compute out a single dimension array, okay, consisting of values of that correspond to that song. Okay, so basically songs such as your category of songs such as True Revines or the Summer Jams playlist can all be represented by an array. All Spotify needs to do for Discover Weekly feature is to find 30 other arrays. You know, so basically each song will output one latent space vector, okay, a single dimension array that represents this song, that represents the various features and various characteristics of this song, okay, such as the mood, the pitch, okay, the tempo, and so on. There will be, in this case, there will be 40 features, okay. There will be 40 features that represents this song. This complex spectrogram will be summarized into this 40 value array with 40 values called the latent space vector. Okay, so what Spotify needs to do is basically to find 30 other arrays that has these similar matching values to recommend to the user. Okay, so it's what they use to analyze the raw audio. So after processing, the CNN will output understanding or presentation of the song, which can include estimated time signature, okay, the key, the mode, the tempo, and loudness. So here's an example of the song Around the World by Daft Punk, 30-second snippet of the song. Okay, so each second they have a different representation of the timbre. Okay, they've reduced the dimension using PCA. The pitch strength, as in how high and how low is the pitch every second. Yeah, the loudness every second, as well as the speed, the change in pitch. Okay, so this is how the spectrogram data is being analyzed. And from that metrics as well, you can also, from those characteristics are basically from those arrays, the 40 value arrays here, right? The latent space vector, you can use those 40 values to plot a visualization, okay, of the artists, okay. So for example, let's give a very prominent example. Let's say pop songs, right? Female pop, Mariah Carey, Britney Spears, Miley Cyrus, Beyonce are all grouped into one segment of the TSNE visualization. Okay, so here comes a new term, TSNE. So what is TSNE? TSNE is basically stands for T distributed stochastic neighbor embedding, TSNE. It is an unsupervised method, a nonlinear method primarily used for data exploration and visualizing high dimension data. So in this case, because there's 40 values, it is 40 dimensions. Okay, so what this does is it lets you visualize the data in 2 dimensions. Okay, depending on how many dimensions you reduce. So TSNE gives you a feel or intuition of how the data arrange in a high dimensional space. So because we are not able, as humans, we are not able to visualize more than 3 dimensions of data in our mind. So we use, to visualize it on a graphic, you need to use dimension reduction techniques to basically reduce the dimensions to visualize them in 2D or 3D plots. Okay. So this is a TSNE representation, and it categorizes singers of the same genre in the same audio vector space. Okay. So that's it for the talk. The conclusion is I've explained on how Spotify applies collaborative filtering to recommend systems based on the data of a user interaction with the songs. For example, how long the user listens to before they click away from the song, how many times the user listens to a song a day, could be what time the user listens to a song, and so on. So it uses various characteristics on how the user behaves on the platform to recommend songs to other users with the same pattern of behavior. Okay. Next, Spotify also applies NLP. NLP, they analyze the song titles and playlist titles in order to, using NLP techniques such as latent semantic analysis, TF-IDF, as well as the cosine similarity, in order to find and recommend songs of the similar playlists. Songs that are grouped together in playlists similarly to the other users that have not found this playlist or have not found this song. Okay, and lastly, Spotify also uses convolutional neural network (CNN) to analyze raw audio patterns, right? To produce the audio vector space so that we can discover which songs are similar based on their audio characteristics such as tempo, pitch, volume, mood, and mode. Okay, so this is basically what powers the Spotify Discover Weekly technique. Okay, so here are the references I've used for this presentation. It's a lot. Okay, so it's not from the thin air. It's really been researched and studied. So lastly, I have a special announcement to make, which is I've been invited to teach at Forward School for their next cohort of the data science bootcamp, the part-time bootcamp on the weekends from October 2020 to January 2021. Okay, for those who are looking to learn data science based in Penang, welcome to join this, and I'll be there physically in Penang to teach this class. For more details, I'll be passing on to Hakim to explain more about the course. Thank you so much.
All right, thank you, Daren. So before I talk about in detail about what Daren just announced about data science part-time certificate, for those who are non-engineers, I understand what you feel right now. It can be overwhelming with all the jargon, with all the calculus theory that Daren have shown us. Even to be honest, I also lost some part of it, especially in the NLP and the raw audio. But to sum up, it's actually like in Spotify, they have this like fingerprints array for that specific songs. And this fingerprint is based on their tempo, their chord, their genre. And using this, Spotify try to identify the similar song to recommend to you. So that's to sum up for those who are getting lost what Daren just said. And before we continue Q&A, so like Daren just announced just now, let me share my slide. It's about our data science part-time certificate program that our Forward School collaborate with Daren. So this is our second cohort actually for this data science part-time certificate program. It's actually a 17-week part-time intensive program that help you with data science using Python, Jupyter, and Anaconda. So it's a Python-based data science certificate program, and it was designed. And our intake for this second cohort will be start on October 2020. To be specific, the first class we're gonna start on 17 October. So what you got? So this bootcamp. So if you know about Forward School, we have two bootcamp that currently we are running: deep learning and data science bootcamp. And our data science bootcamp is 17 weeks. It's a beginner-friendly bootcamp compared to our deep learning bootcamp, which is 2 months. It's 8 weeks. It's advanced bootcamp for those who already have a solid foundation. But for our data science bootcamp, it's 4 months and beginner-friendly. So if you have zero knowledge about data science, or you just want to get started with data science, if you are either programmer or even if you are gardener or even you are physicist, if you want to do a simulation or physics simulation, if you are interested to jump into this kind of field, I would recommend to join this bootcamp. And what you're gonna learn in this program or certificate program, you'll be able to learn how to use Python code to actually to do data analysis in data science, and also how to prepare your data so that we can perform data analysis or data science application, and also data visualization. And there's a lot more like classification method, concept of including, overlifting, and many more, and bias, how you can set your bias for your data analysis and to make sure that it's not biased on certain data, and able to understand what the working principle of the mathematics or the calculus theory that being used to actually do all these calculations, how to decide whether these songs to be recommended to user or not to be recommended to user. So this is what Daren gonna teach at our school every weekend, beginning at 17 October this year. And this curriculum is just a brief to what you're gonna learn in each week. So week 1 to 3, we cover the fundamental about Python language, and then we're gonna learn about how to prepare the data. So you can, let's say you are trading stock, for example, if you love to trading stock, how you can get all the data, actually prepping the data so you can do the data analysis. And then you start with the meat, which is statistical and modeling, how you can understand what kind of method is suitable for this particular data, or things that you want to extract from all this huge data collection, or what you can learn from it. And then you learn about machine learning method, what the algorithm you can use on particular situation. And also, the best part about this certificate program is you will be able to build your own project. We have a capstone project that you need to submit at the end of the program. So you can apply what you have learned throughout this 17 weeks. So for example, our last cohort, they actually build their own capstone project, and they're going to present to our industry partner and also our hiring partners as well. Right. Let me change my slide. Yeah, so again, our instructor is going to be Daren, and he's a full stack generalist and also data scientist. I think he already explained a lot about himself just now. So yeah, so Daren will be coming to Penang, Georgetown, in the center of Georgetown, where a lot of tourists is very close with a lot of tourist attraction as well. So if you want to have the experience like come to Penang, enjoy yourself, also learn at the same time, I'll totally recommend it for you. And this is our student for our last cohort. They graduated from this program on July 2020. And you can see there's several projects, which is their final project that they actually present to our hiring partner and our industry partner, which is analysis on factor, like say heart disease factor, visualization on pre-equipment management, also shop floor station for product failure rates. This one is for more into like manufacturing and telco customer churn. Also, our best project, the student that actually won best project for this cohort is actually the one that do the project of COVID-19 drug discovery. So she get all the information from Kaggle. For those who doesn't know, Kaggle is a place where all the machine learning AI enthusiasts go and to get data, also to compete with competition. And she used all this information that are being shared to see what kind of drug that can actually effective to help to reduce the symptom of COVID-19. So she won the best project for last cohort that we had in July 2020. So you see, last cohort we have 8 students, and for this cohort, since we got a lot of demand on this data science certificate program, so we decide for the next cohort, for the October, for the next month, we're gonna open only to 12 slot. So if you are really interested, you can apply after this session. I will put the link in the chat so you can straight apply. So you just apply if you're keen, because I will call you back to really understand about you. So we not just taking student like randomly. We do call you to understand who are you and what you want to do with this program, and we will make sure that this program actually is suitable for you. So don't worry that we get. There's no losing if you just apply to this certificate program. Why is keep coming back to the all? Okay, so yes, again, this not an cheap program, so it's quite expensive. It's actually, let me go to the pricing. So the full cost is 12,200, and if you want to do installment, we also open for installment for 12 months with 1,071 ringgit per month. I know it's expensive and it's not for everyone. I totally understand. But what you get for this price is 16 full length or on-site classes. So you have the option. So if you, let's say you are from KL and you're unable to come to Penang every single week, we totally understand. So that's why for our certificate program, we already set up, we already have equipment that actually can accommodate remote learner and also learner that come to our campus physically. So you have the option whether you can come to the Penang itself to join physically, to meet Daren face to face, to ask questions. And you can also either opt to, let's say, you doesn't feel well, want to stay in KL, can I join remotely? Yes, you can. So you join remotely, and our equipment is very high tech one. You don't worry, you can just simply unmute, you can ask questions, everyone in the room can hear you, and there will be a lot of problem. The Daren will use whiteboard to show you, and you can see the whole classroom as well. So we already implement a very high-tech remote learner experience as well. So if you have this difficulty to come to Penang as well. And also you would at the end of the book, the program, you should have your own GitHub account. So for those who are developer, those who doesn't know what is GitHub is actually, I would say it's a resume if you're a developer or even a data scientist, for you to show to your potential employee, or even to show it among your friends. And then you also have access to state of the art of our online learning portal as well. So for those who are not familiar with our school, we have our own learning portal, which is designed focus on the learner, not of us. So it's very hard for me to show you guys the best thing about this learning. But what I can say is you will learn more effectively using our learning management system. And then we also have Daren on site with us, and flexibility. Like I told earlier, is to do remote learning and also get a certification from our school. And yeah, so go back to the funding option. So we know, like I said, it's not for everyone. I totally understand. That's why we foresee that there's a student that really high potential to get to this program and really can benefit from this program. Maybe you want to build something that actually benefit for your community, or do you want to build something that actually can benefit to your company, or even small, medium, and enterprise. So we have these three options for you to opt. So first, we have a scholarship program, and we only have 7 seats for this scholarship. So if you want to join this program and you want to get our scholarship, do apply now, because our application is gonna close on, I think, in less than 30 days. So make sure you apply so that I can call you and I can understand you more about you, and I can explain to our committee, our scholarship committee, who are you, so they can make decision whether to grant you the scholarship or not. Second, we have also monthly installment plan. So you can use your credit card and yeah, normal installment lah. So okay, you can use credit card for 1 year installment. And then third is HRDF claimable. Say, let's say you are building this project for your company, you can claim HRDF, and we are HRDF claimable. So that part we can help you manage how you can fund your fee for this program. Yeah, so that's the three funding option that we can offer. So, and do remember that scholarship is only limited to 7 seats. So if you are interested, do apply. I will put the link in the chat session after this. All right. And yep, I think that's it for me. And you want to learn more, go to our website, forwardschool.co. Go to program-packages/data science. And the application deadline gonna close in 1 October. So that's means less than 20 days, something like that. So if you want to join and get, especially if you want to apply for a scholarship, do apply now, because we need more time to actually grant you a scholarship. That's and we only have a 7 seat for it. All right, I think that's it for me. And I believe everyone have a lot of questions. I think you guys are still holding up your question, or if you want to put your question now, you can put now, so Darren will answer it for you. All right, without further ado, I will get back to Darren. Are you there? Are you ready? We're going to go to Q&A.
Yep, I am.
Okay, cool. So let's see our first question. What is API? Okay. Okay, I foresee you probably not from software or computer, so it's fine. Maybe we can briefly explain what is API, Darren.
Sure. So API, right, stands for, it's a very common term in the software development world, where API stands for Application Programming Interface. So in layman term, it is how two systems communicate with each other. It's a method for two systems to communicate with each other. So let's say, for example, let's say Twitter APIs, right? They have APIs for you to get real-time tweets. They have APIs for you to get real-time profiles, followers, and likes. So what you can do, right, when you're building your software, your system, to get this data from the other system, which is Twitter system, they communicate through APIs. Okay,
I see.
so how API works is that you can either send a few different HTTP requests, such as post or get methods, which is used for different situations, alongside with authentication method, and then you retrieve the data, and normally typically in JSON format, and then you can use it to build a system. Okay.
All right, thank you, Daren. So we just so the question is coming in. So let's go to our next question. I hope that answer your question. I'm not sure who are asking the question. What is API? But I hope that answer your question. So, any advice for mid career working adult who has no experience in software engineering but keen to move into data science field? As most of the job ads require someone who has experience in data science project. Thank you. So, if I would like to rephrase his question, is basically, so for mid career working adult, okay, mid career working adult who no software engineering background but interested to jump into data science. So what do you think about this? So because his concern is that most of job ads require someone who have experience in data science project.
Okay, so for this, there's multiple ways to go about this lah. So from my observation, let's say you already have software engineering background. Yes, because data science itself is not just about programming. There's also different fields, such as it requires 3 different fields. Let's see. Data science. You need to know how to how to program, how to write scripts. You need to know maths and statistics. You need to have business and domain knowledge. So this is what data science constitutes. So if you want basically to apply for job ads, right, you can always start with the junior role. Okay, the junior role, but of course, to apply for the junior role, also you need to have data science experience. And how you can do that, right, is to learn up data science, either by attending boot camps or online courses or whatnot. And after that, once you learn, you can do mini projects surrounding various areas of data science. Could be audio analysis, could be news analysis, could be just whatever topic that you are passionate in, right? You do a few of them to demonstrate your capability. To be more specific, it will be even better if you can find out, for example, let's say you're applying for Touch and Go. Let's say you're applying to enter Touch and Go as a data scientist. So what data do they deal with? They deal with financial data, they deal with transactional data. So if you can reverse engineer, right, you want to enter a financial, a fintech company or financial, the company that heavily dabbles with financial data, you would want to reverse engineer and think, okay, I need to prove that I know and I can do data science analysis or to apply data science techniques in fintech or financial field. So I need to do multiple mini projects or learn how to apply data science into those data sets. So you can find data sets online such as Kaggle and open government open data. Malaysia
My
one
data.
is, yeah, correct. So Malaysia one is opendata.gov or something. And also multiple governments also have, Bank Negara also have open data, if I'm not mistaken. You can have a look. So basically find transactional data, and depending on so it seriously depends what company, identify your end goal, what's your end company, and then you reverse engineer the steps you think you need to enter that company, so you can be more focused and not waste time.
Yeah, so to summarize, basically, I mean, I would say it's similar. Like, it doesn't matter what domain that you are coming from, because the data science more or less is like a tools, like how computer coming into business in the early days. Back in the days, like when people not familiar with computer, they see computer as like, wow, what is this? We don't understand how it can do the calculation in one screen. But then, even though either you are business or whether you are in the education sector, computer come in and we help your work much more faster and make much more efficient. So basically, I think it's the analogy is like, yeah, like that is like, if you, let's say you are a gardener and you have the knowledge of botanical and how to grow a plant effectively, and you can use data science and make your own project, how to analyze what the best soil ratio that best to grow specific plant, and maybe you can predict, oh, this plant is from this family category, or can just put the data and the data science, I mean the CNN or machine learning can do all the calculation. Oh, this is a best soil ratio to plant this particular flower or plant. So that's a thing that I will get from what the parents say, and I would like to take this opportunity. So that's why in our certificate program we have I mentioned specifically about GitHub account. So in GitHub is where you put all your project also, so you can showcase to your future employers. So more or less, if you apply for software engineering or even a data science job, that we ask for GitHub because it's the best way to, I mean, that's where you put you showcase your project and what you have done previously. So yeah, I just take this small snippet to promote again. Sorry, okay, let's go to the next question. What is the prerequisite to join the courses? Do prospective students must have a good math? Okay, there's two questions. So what the prerequisite to join the courses, and do the student need to have a good math? Okay, I think, okay, I will answer the first one and I will pass it to Darren to answer the second one. So to join the courses, so like I mentioned earlier, is beginner friendly. So that means if you doesn't have much experience with programming language, so we were going to cover, we have a prep course for you. So we have prep course for programming language in Python for you to go through first before you come to the first class. So in case that you doesn't have a software engineering or never have any coding programming before, you can still join and we will see whether you are a good fit for this program. And if we feel you have a good motivation, you have got courses to join this, we will have you, we will give you access to our prep course for you to go through before you join the class with Darren. That's why we ask for those who are interested, apply earlier so we can understand, oh, you are a beginner, so you can have more time to work with the prep course, so you can take it slowly and catch up with the rest. Then you can go to Darren, with Darren to further with the courses. And then second question for Darren is, do students need to have a good math? Yeah, what do you think about that, Darren?
Mm, of course, I believe if you have the passion and you really want to become a data scientist, you'll be able to pick up, learn it up on the job, or rather, to learn it up for the sake of becoming a data scientist. So having the math knowledge, I mean, most of in day to day, mostly you'll be using the libraries a lot, so you don't need to touch the maths. But however, when it comes to more advanced cases, such as when you need to tweak the parameters to get, because let's say the default settings or the default parameters that's in the library doesn't work well, okay? It doesn't work well, and you want to improve the accuracy or to tweak it so that it works for your case. So in that case, you need to deep dive onto the code and deep dive onto the maths on how you can, on what each parameter affects the library or the output. Okay, so that's when you need the math. So definitely, to answer your question, yeah, having maths does help. If you need to, one, tweak existing libraries, two, to devise or devise new methods or new techniques to.
I see, I see. So to summarize, yes, it's the best if you have the math, so you can, when you do the program or the script to run the machine learning or CNN, you know what is happening, so you can make a reason. Oh, why this happening? Why is it's not happening like this? Why is come out with this outcome? So it will help you to have a better intuitive in data science field. So I hope that answer your question. Ruzi, is it? Okay. I hope that answer your question, Ruzi. Second, we have how do you see data science in the future?
Wow, okay, that's a very broad question. So it's not the future anymore. It is now. Data
Yep.
science is now, because everywhere, every industry, you will see data science. You will see in financial data, in the financial industry, you can see in the beauty industry, where people analyze which models look similarly faced, or even similarly what is defined as pretty. You can even find data science in food industry, where they analyze and they can find out food, what is defined as delicious and not delicious, or what ingredients it takes to make certain food or to derive certain taste. Perfume industry, where certain companies like L'Oreal have used AI to generate new perfume. New perfume fragrances, yeah. They've also used data science in medical field, of course, to determine COVID, where COVID was spread, when COVID was spread, how to cure COVID, and so on. So yeah, data science is everywhere. So best to, if you want to become data scientist, it definitely will be in demand for the foreseeable future.
So to summarize, basically, it's not the future, it's now. It's already around us. Yeah, we just don't see. That's the thing that I think a lot of people don't realize, that actually data science, AI, machine learning is already around us. We just doesn't see it as a machine learning. We see it as a recommendation system, a prediction system. So actually behind the scene is all machine learning and data science, algorithm and program. All right, I hope that answered your question. I don't know what the name, anonymous attendee. Okay, it's fine. Next, we have question from Kairun. What the difference between machine learning, deep learning, AI, artificial intelligence, and neural network?
Okay, I prepared for this question.
Okay.
So, hold on a minute. Let me share my screen. Give me a few minutes to prepare. So that reading and seeing is easier.
The diagram, is it?
Yeah. Adjusting the text size 20. Okay, share screen 2. Okay, can you guys see my screen?
Yeah, I can see safe. Okay. No.
Okay.
Yep.
Yeah, so hope this diagram easily illustrates it. So there's actually multiple definition of data science, but this is the one I follow lah. So data science is the umbrella term. It's umbrella. So underneath data science is artificial intelligence, and within artificial intelligence is machine learning, and within machine learning is a subset called deep learning. Okay, so to explain in words, right? Data science is the process of pre-process that involves data. Basically, all things that involve data. It is a process that involves pre-processing, data cleaning, analyzing, visualizing, and making predictions. Okay, so for AI is a subset of data science where you implement certain machine learning models to make predictions, to forecast the future. Okay, and then so basically, in essence, data science is comprises of various statistical techniques, whereas AI makes use of the machine learning algorithms. Okay, and deep learning is a subset of machine learning algorithms. Hope that answers your question.
I hope that answered your question, Kairon. The diagram I think help a lot. Next, we have a question from Hanafi. Is there any difference between data analyst, data engineer, data scientist? Can you give an analogy to differentiate these job roles? Yeah, I think this is something that I'm also interested to know.
Give me a second. I also have a diagram to show for this.
Oh, okay. Great.
So yeah, all these three roles are vastly different. Okay, although they are closely related, but it is very, very different. Let me try to illustrate. On a minute. Okay, let's go through this block. Sharing screen. Okay, can see your screen, huh?
Yep.
Okay, so you can see data analysts, data science, and data and they work with data. That's the only common thing. But other than that, they have nothing else in common actually. So data scientists, professional in programming, mathematics, and business analytics, okay? They gather, clean the raw data set. Okay, the language they need is also different, SQL, Python, R. Okay, this is what data science need. They will take the data science project from end to end, from start to finish. Okay, doing the sort of the core stuff, which is processing the data, create predictive modelings, and presenting the findings. 3 things. Okay, analysts is I would say more beginner. They're more entry level. They have decent knowledge of mathematics and good business acumen. So what they do is they will create reports, mostly create reports, create dashboards. They work a lot with Excel, Tableau, SQL. So data science, more programming, data analyst, less programming, more SQL and more data visualization tool and Excel. Okay, so what they do is they help people to get basically to query for data lah. Okay, query data, generate visualizations, these two things. Okay, so they normally generate those reports on weekly, monthly, or quarterly basis. Okay, next we move on to data engineer. Data engineer is the hardest, I would say, among the three, because this is the person that's involved in the DevOps side of things. They need to design, build, integrate, and maintain the data source, the data hardware. So, example, you need to store huge amount of data, big data, right? You need a different type of data architecture. Okay, data hardware architecture. So they have the knowledge in SQL, NoSQL, Cassandra, as well as the Spark, Hadoop. Okay, so what they need to do is they need to, they need to set up they need to help to set up and store the large data set that's incoming. Example, let's say, yes, the data scientists can scrape data, but how will they store the data in real time, right? Real-time streaming data, that is not easy. So data engineers will take care of that so that the data is stored real time, doesn't crash, doesn't backlog, and the data scientists can use the data easily. Okay, so other than that, right, here's the breakdown for the three different roles, what skills are required. Programming, as you can see, data analyst requires very little machine learning knowledge, whereas communication needs to be high because you need to communicate to programmers as well as the business people. And data exploration, you have to explore data a lot. So as you can see, throughout these three roles, there are common skill sets required, but required in different intensity. Okay, here's language required. Let's have a look. Data scientist, architect, and engineer. Okay, ignore the architect. That's a story for a different time. So yeah, so as you see, they do require some common languages, but there are some that's only required by certain roles. Okay. And lastly, of course, the main question that you should actually determine first before you want to explore any of the roles. First of all is two things for you to determine. One is what kind of job scope you like, what kind of job scope is your passion. Number two is which one pays the most. There's two ways to determine what role to go to. So as you can see, data analyst, the job being far simpler is being paid lesser. Okay, this is Glassdoor data. So among data scientists and data engineers, they are paid about the same. These are annual salary in the US probably. Okay. So yeah, hope that answers your question.
Yep. Yeah. Is it Hanafi? Yeah, I hope that answered your question. And then we have question from, okay, what type of project that should a software engineering undergraduate focus on during university?
Okay, so for this one, there's actually many. So I would say the best one would be the one the area that you're most passionate in. Find an area that you're most, either is passionate in or a real-time event, right? So I mean, a very recent event. So for example, back in my time, 2015, 2016 would be, let me think. Back then they have an incident where I think Middle Eastern boy in the US, Arab boy, he brought a homemade clock to school. Okay, he brought his own. Yeah,
Yeah.
he brought his invention. I mean his project, hardware project to show to the school. Then the teachers or the friends or parents or whatnot reported the police, and it became a huge incident. So back then it was a very recent event, quite a popular event. So I used that as a data science project for my undergrad in the assignment. So I got high score for that, and also I used that to present in a subsequent job and also freelance prospect. So what I did for that project was I did an end-to-end project where I scraped the data from Twitter real-time tweet API. Okay, I scraped 1 week of data that was using R Studio, using the language R to scrape. After I scraped 7 days of data, which I left the thing running, I left the thing running for 7 days. Then after that, I clean the data. Basically, what I search for are tweets that, right, I stand with Ahmed. Ahmed is the name of the boy. So from there, I do multiple analysis based on the data after I clean up. I visualize it and make a storyboard based on it. That one I use R Studio as well as Tableau. Tableau is a very expensive but back then a student you can get it for free actually. Tableau is also in demand, very in demand skill. So yeah, from that one project, I demonstrated that I can do data scraping using R, I can do data processing using R, I can visualize it with Tableau and visualize it in a meaningful way. So blindly visualizing is useless. You need to have a flow. So I should show, okay, based on the 7 days, which days get mentioned the most. So you know when is the peak of the news, when is the low of the news, so that you get a time-based analysis. After that, you can also get which country geographic analysis. So you know which country the tweets come from, that which country supports Ahmed or feels strongly about Ahmed the most, about this incident. You can also find out different things such as what words were used to support Ahmed. Is it positive? Is it negative? Right? So yeah, you just need to find either a area of passion in, could be combined with your who's the carpenter or what. Yeah, you can combine it with any industry. You can find data science with any industry, and you find the industry you're passionate in, and then you try to find projects or problems that you want to solve, things that you can do, and also you can explain very very passionately. Okay.
Okay, that's. I hope that answer your question. I don't know who asking the question, but yeah, that's something that you can look into if you are try to do project. And I think the next question also kind of similar from D. Srinivasan, where to find idea for simple yet comprehensive project to be included in our resume. Yeah, I think this is almost similar, is it?
Yeah, similar, but never mind. Just to elaborate onto the previous one, I'll share my screen right now. Share. Okay, so basically a simple Google you can find lah. Okay, let's see, fake news detection. Yes, you find a data set of, there's so many projects you can do. So fake news detection is one. I'm not going into details. Road line detection, which is a video analysis using Python. Okay, sentiment analysis, positive, negative, as well as now in recent years, Facebook has different reacts. You can also predict each comment is related, attracts what emotions. Okay, that's also one. Detecting Parkinson disease. So you can find data set for the using from the UCI machine learning Parkinson data set. You can get the different characteristics of data of Parkinson to predict if the person has or does not have Parkinson or not. Okay, brain tumor leaf analysis. So you can go, there's in this website, it's very good data flare training. There's they separate out to beginner projects, they separate out to advanced projects, intermediate projects, as well as gender and as well as advanced. Okay. So yeah, feel free to Google and you can find many different ideas. It's 100,001 ideas for you to try out.
Interesting. Yeah, I hope that answer your question, Srinivasan. Next, what hardware setup is recommended? This is quite vague. So I would assume you are asking about hardware setup for your PC for data science. I guess. I hope that correct. What do you think, Daren?
Well, that definitely depends. So it depends on what kind of projects you do. So if you're mainly if you're doing neural network, you're doing deep learning, you're doing machine learning, some of it that can utilize some of the libraries such as what's the name?
PyTorch,
PyTorch, TensorFlow, all this stuff.
Panda.
Yeah, some of it that can utilize multiple core processor and multiple core GPUs. Of course, that is the best. But however, right now, as of 2020, you don't need to set up your own hardware anymore. There's something called Google Colab, if I'm not mistaken. Google Colab comes with, you can use it for free. It comes with an amazing amazing free tier for you to, that comes with NVIDIA NVIDIA, I forgot what's the name of the GPU, but it's a very high-end machine learning GPU. Okay, so if you have anything that you want to try out that's super intensive, you don't need to buy your own hardware, you can use Google Colab.
I see. I hope that answer your question. Then we have a question from Jingzi. How do you have any advice for CS undergraduate when looking for internship? Like what should expect to equip or learn during the period? Okay, so it's basically what to learn or expect during the internship, I think. Is it correct? Yep.
Okay, so basically he's asking like what should a CS undergraduate look for when looking for internship? Let me think. Of course, you want to find ways to find a good internship is there's a few ways. One is you talk to the employer. Sometimes it's not just about you getting the job, it's also about whether it's the employer suits you or are you comfortable with the employer or the company or not, right? So one of the best ways is first of all, talk to the employer or the hiring manager. If you're comfortable talking to them, do they know their thing, or is it like one man, they expect you to be one man show? So you should be able to detect that during interview. So it's not just them interviewing you, it's about you interviewing them as well. Two, you need to find out about the company's reviews. So Glassdoor, you can filter for internship experiences. You can see what other past interns or past staff their experience were. Okay. Other than that, you can always talk to friends or your alumni network of your university to find out who has interned at this particular company. Talking to people face to face on Facebook helps a lot. Okay, so basically you need to ask the right questions to find out if you can learn from the company. Number two is what kind of working environment, and will you actually have someone to guide you, or are you expected to self-learn everything? So best is to find companies that are able to have a strong team. I mean, have a team and also established processes, and also a good leader or good manager that will actually be able to teach you things lah.
I hope I answered your question, Jingzi. Next we have what skills should a degree focus on to become a full stack dev and also to remain competitive with students from other fields such as AI or data science?
Wow, very broad.
Yeah.
Let me think. What skills?
What
So you need to
skill?
decide yourself. Do you want to become a full stack dev or you want to become a data science or AI person? So it depends. So do you enjoy building web and mobile applications more, building software applications more, or do you enjoy working with data, discovering insights, producing visualizations, producing prediction models, producing clean data? Most of the time in data science is to clean data, right? So it depends on your what's your goal for your future. You want to become a developer or to become an AI data scientist?
So in the end of the day, it's still up to what domain you want to be master in. I mean, to be specialized. Yeah.
Right.
Yeah. So we have a question
Last
from my
question.
let's
I
okay
think the last
let's
question.
keep let's keep we're gonna close our. So if you have any question, put it now because we're gonna close our session. So let's answer all the remaining question. So from my Sarah, so web or mobile or software developer is more likely easier to work as a data engineer roles.
I don't think that's related much, but having a software developer background does help you to pick up the language required for data engineer role more. For data engineer, let's see, required skills. Yeah, for data engineers, you need to know about data architecture, how to engineer the different levels of data architecture required for different scenarios, because AWS, all these cloud hosting services, when you create the data architecture, you need to know how to achieve most with the least amount of money spent. Okay, of course you can scale up manually, like you can just scale things up as it is, but however that will incur exponential costs for the user. So it also comes down to how you minimize the cost while maximizing the effectiveness of the data architecture. So other than that, you must be good at knowing what other database solutions are out there, what's the pros and cons of each database, how you can link them together to form clusters of database, how to use in-memory caching, how to do data warehousing and ETL tools, Hadoop, and also having a very sound knowledge of various operating systems, such as all the different Linux distributions, such as Ubuntu, Kali, what else, CentOS, and so on.
All right, I hope that answered your question, myself. So yeah, it's not like directly you can like easier. I won't say
Easier.
it's easier. Yeah, it won't be easier. It's like yeah, it's up to individual as well. Okay, to next is from Kairun. If TSNA is used for audio analysis, what was used for graphic analysis like face recognition or self-driving car? Okay, this is interesting.
Mm, graphic analysis. So TSNE actually is domain independent actually. TSNE can be used for any form of data, which is for TSNE can be used for any form of data that comes in the form of that can be converted to matrices. So example for graphics, right? Graphic is also example, let's say you have an image of 512 times 512 pixels. So basically it's a matrix of 512 times 512 is a 512 times 512 size matrix. So from there you can apply TSNE to perform visualizations. However, whether or not the TSNE produces meaningful visualizations, that you need to test it out first.
Yeah, correct. Because I'm not an expert, but I know a little bit about deep learning and face recognition. So if you are processing like images, usually what the engineers do is we split up to the color spectrum to RGB. So one image to to red, green, RGB, blue, and they do metrics based on this color, and then I'm not really sure, but that's how they. I forgot what is the method or algorithm that they use, but it won't be. I mean, I never heard TSNE in deep learning. That we have a bootcamp in deep learning, but I never heard they use any TSNE for image processing or image segmentation, per to say lah. So just my 2 cents on this. Don't take my word. All right. Okay. Let's say we have last two. So I will keep the Srinivasan as the last one. Okay. Let's answer the. Do you scrap web for data when it doesn't allow? Oh, okay. Okay.
Oh,
Whether
of
data
course,
scrapping is
definitely.
legal?
No. I mean, not to say if it doesn't allow. So, of course, there are certain websites that has methods. I've encountered situations where you need to scrape data when the website does not allow scraping. There are some
API.
measures in place to prevent scraping. So one of the common example that you might face is the JavaScript, whereby the page only loads if it is a browser that loads the JavaScript. So actually, and also paywalls, right? uh, Websites with script blocker and all those. So there are actually ways, as well as if you do data scraping where you scrape very frequently from the same IP address, they will ban your IP address. So yeah, they do have methods to mitigate each of these situations. You can actually find out while you are when you do a simple Google search and you do spend hours on analyzing how to bypass each method. There are ways to scrape them basically.
Interesting. Interesting. All right. Lastly, from Srinivasan, what keeps you going? So very broad.
Very broad
Uh,
question. And well,
whoa.
let's say in perspective of giving talks or being out there to run developer kaki and stuff like that, or even day-to-day work, I would say is the grander vision lah. My passion is to first of all is help developers, help students, help the tech community basically. Number one, help them grow, help them to gain the knowledge that you previously can't really get, to democratize the example, the job, career prospects, knowledge, as well as to spread, to explain and teach about different areas of the tech knowledge lah. That's what keeps me going.
Yeah, thank you, Daren. That's very inspirational. So I hope that answered your question, Srinivasan. And that's it for our Q&A session. I hope everyone have gained a lot of knowledge today and gain the value from Daren sharing and from our Q&A session. And again, I would like to remind everyone, if you're keen to join our part-time certificate in data science, which is we have Daren as our instructor, do we have a link in the chat, and do apply if you, especially if you are looking for our scholarship, because we need some time to process it. And that's it for me. I would like to thank you everyone, and thank you for tuning. Let's see how many. So we have 25 still until the end. So if I'm not mistaken, we have around 37 when we start, and now we still have 25. It's very good numbers. As well, I'm really glad there's a lot of people that's stay till the end to actually stay for the Q&A and ask questions to Daren. And I hope everyone get beneficial input from tonight's session. And that's it from me. I hope everyone have a good weekend. And thank you, everyone. And thank you, Daren, for tuning in for tonight. I really appreciate it. And yeah, that's it from me. See you, everyone. If you have any opportunity to come to Georgetown, please do visit Forward School. I will be there, or even on my colleague, or even when the class is going on, maybe you can see Daren as well. Right. Thank you, everyone. Bye bye. Thank you,
Bye, guys.
Daren.